Okay. So now we got a tough one. Three letters. Three letters. So start out. Each column will be represented by three letters: P, Q, R. Now, what should go next after that? I always put, if there's no negations, then I would put the statement in the parentheses. So that's Q and R. And then finally, the entire statement we want to evaluate: P or Q and R. This part is a little bit trickier, but it's the same idea as when we had two letters. I am going to list for each of the three statements, P, Q, and R, all the possible combinations of values that they could have. So, firstly, all three statements could be true. So, that's going to be the first row I fill out, all true. After that, this is just how I do it. I'm going to fill out every combination where there are two true statements and one false statement. So that could be that P is true, Q is true, and R is false. That could be that P is true, Q is false, and that R is true. And finally, it could be that P is false, Q is true, and R is also true. So those are all the combinations where we have two true statements and one false statement. Now, after that, I'll list every combination where there is one true statement and two false statements. So P could be true, and Q and R can be false. We could have that P is false, Q is true, and R is false. And then finally, we could have that P is false, Q is false, and that R is true. And lastly, we could have that they're all false statements. So P is false, Q is false, and R is false. So those are, and again, if I have three letters, this is how every column I fill out will look all the time. That's because I just apply the same sort of algorithm, the same sort of process each time. Then we have the Q and R row, or column, I should say, sorry. So I'm going to look at the Q column and the R column and join it with an AND statement, meaning both have to be true for the conjunction, the AND statement, to be true. On this first one, Q is true, R is true, the conjunction must be true. Q is true, R is false in the next one, so that means the conjunction is false. False for Q, true for R, that means the conjunction's false. Double true gives us true. Double false gives us false. True and false give us false. Q is false, R is true, that's another false, and double false is false. So, again, just fill it out looking at the two columns that you need. And now we have the last one. And again, same approach, right? Look at my, I need P or Q and R. So I'll label the P column as like 1. And then the Q and R column is 2. So all this really amounts to is the column 1 or column 2. Again, only look at two columns at a time to evaluate the third one. Since it's an OR statement, only one of them has to be true for the entire thing to be true. So, column 1 is true, column 2 is true, that's true. Next, we have P is true, Q and R is false, but that's still true since it's a disjunction. P is true, Q and R is false, that's another true. P is false, but Q and R is true, so that's another true. P is true in the next one, Q and R is false, but that means the disjunction is true. Now we have P is false, Q and R is false, so the two falses will be false. And it seems like it's that for the rest. And there you have it. That is how you can solve a basic table with 3 statements now instead of 2. A little bit more work, a little bit more tedious, but as you can see, just apply the same set of rules we've been doing the entire time and you will get your results absolutely. And now we can see why these tables are useful, because it allows us to generalize complex statements like P or Q and R, and from that we can like later on develop equivalencies and stuff like that, but that'll be somewhere down the road. Let's not worry about that for now. And if I have time, I'll make another video on another one of these 3-letter problems to help you out.